prefix by means two. So it's talking about two different variables. So basically the order pair is representing like miles and hours, or the cost of a house and the cost of the utilities. Things like that. Two different things that are going to be compared on the same graph. Scatter plots can help determine if one variable has an effect on the other, or if there are overall trends, patterns, or association between the variables. So association is how those points are associated with each other. And there are three types of associations that we're going to talk about today, and that's what the main focus of today is when I look at this scatter plot, do I know what that relationship is between the data that we see on there? Okay, so the first part says, Zara surveyed shoppers at a mall to see how many items they purchased and the total amount of money they spent at the mall. She used the data to create the scatter plot shown. So it says, how many shoppers did Zara survey? Does anybody have any ideas on how I can figure out how many shoppers that she surveyed, Karen? And count them. Count the dots. Because every single dot on that scatter plot represents somebody that she surveyed. So like, this person bought 2 items and spent about $18. This person bought 1 item and spent about $40 or $35. So you can look at it and tell what they bought and how much they spent. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 dots. So that means that she surveyed 16 shoppers. Okay, it says, does the number of items purchased seem to have an effect on the amount of money a shopper spent? So look at the points, look at the items that they spent and the money, or the items that they bought and the money that they spent. Hold on, all right, think about it. What?
No, because 2 of them have 1 item but they're different prices.
Okay, well they're not asking about just specifics, they're asking me of it about as an overall thing. Looking at all 16 shoppers. So let's all think about it for a second here. Our Chromebook should be closed, it should not be on them. Some people are currently touching their Chromebooks. Alright, so let's talk about here. So like I said, 1 shopper spent about $35, or 1 item, 2 items is about $18. 4 items is about $35 again. But it looks like as the items increase, so does the price. So would you say the amount of things that they buy affects the amount that they spend?
Yeah.
Yes. So it does look like the more items bought, the more is spent. Because when you read that, we read a graph from left to right, just like we read a sentence from left to right. So as I'm reading this, I'm increasing in my numbers of items, but I'm also increasing in my money spent. So it does have some type of relationship between that number of items that were bought and the price. And down here, we're going to learn that type of relationship is called a positive association. When you read it from left to right, that graph is going up, just like when we talked about slope. When I looked at a line from left to right with slope, if it was going up, it had a positive slope. So if the points are going up from left to right, it's got a positive association. So that means as one variable increases, the other variable also increases, which is what we saw above. As the number of items increase, so do the price. Notes paper. We haven't even got really into anything yet. So, all right, the variables change in the same direction. So they're going up, 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 up. association. See how I read the graph from left to right? See how the points are going down from left to right? That's the negative association. So as one variable increases, the other variable decreases with a negative association. And that means that the variables are going in opposite directions. Once again, the best way to figure out positive and negative association is to read the graph from left to right, to see the trend, the majority of the points, which way they're going. Because the scatter plot doesn't go in a straight line. A scatter plot is what it says, the points are scattered. So you have to look at the majority of the points and see where they're going, not all points one for one. You're looking at it as like a chunk of points. And then this one, if you were to read this from left to right, is it going down? Is it going up? No, and that's what we call no association, okay? They don't have anything in common. One variable has no effect on that other variable. So here's an example of no association. Your hair color determines how many animals you have at home. Does that have any type of association with each other? No, no. Or your address determines your shoe size. That's dumb too. That has nothing to do with each other. But a positive association, like we said of the one above, the more items you buy, the more money you spend. Or the larger your house is, the more utilities cost. Anybody have any ideas about a negative association, maybe? What was something that would be negative? Right, like?
The more you use your car, the lower the value is.
Yeah.
Yeah, good job, George. That's actually a really good.
I'm very proud of you.
Okay, so down here, just like what we were saying out loud, okay? They're going to give you an example and they want you to say, does this have a positive association, a negative, or no association? So don't yell it out if you already know in your head. Just kind of let everybody think about it. So it says, describe the type of association you'd expect to see between the following variables and explain. So number one, the number of shoes a person owns and the number of states they visited. So think about if you think that would be a positive, negative, or no association. What do you all think? No association. Okay. Also, Blake, ready? If you're going to abbreviate association, let's not stop there. Let's put like a no on it. Okay?
I would never.
And it's no association because the number of shoes. Okay.
What is that?
I don't know.
That's the back
Oh, that's the back?
Yeah.
How you're paying.
I delete it, I was like,
Alright. So no association, number of shoes does not affect states visited. It does ask you to describe, so that's why I'm writing a description there. Alright, number two. So on your own, I want you to think about it. The size in ounces of a steak and the cost of a steak. So don't yell it out, everybody think about it. Alright, what do we think? Positive. It is positive. Because the higher the ounces of the steak, the more it'll cost, right? So more ounces is a higher price, or is increasing the price, or the cost, or the money. All right, and then the third one, the number of days since watering the plants and the moisture level of the soil. We'll all think of that one for a second. Anybody have any ideas on that one? Okay.
Negative.
It is negative. So when you water a plant and you don't come back to it for a few days, what happens to the water in the plant?
It's dry.
It's getting dry, right?
Yeah.
So the longer you wait in between days of watering plants, the lower the moisture level is. So the more days you wait, the less moisture is in there. So that's what makes it negative, because they have different variables. So one is increasing, one is decreasing. Whereas with the cost of the steak, as steak size went up, costs were up and up. With the water level, more days, less water. Less days would be more water. But it would still be a negative because they're different. One variable is increasing, one variable is decreasing. Alright, so this is negative. So the more days, the less water. Or less moisture. Alright. So on the back, there's types of associations. There's strong associations and there's weak associations. So if data points are very close together, so if the points are like super smushed together, then that is a stronger correlation or stronger association. They use a correlation association. So this, since the points are really chunked together, this is a stronger association because those points are a lot closer together. But if the data points are a little bit farther out from each other, they're not so packed together, that's when our association is weak. So this one is weak because the points aren't packed as close together. And then linear versus nonlinear. Everybody always freaks out. I'm like, I can't remember what linear is. What's the first four letters spelled? Line. So I know scatter plots are not going to be a straight line, okay? But the shape of them is what this linear and nonlinear is talking about. So if you were just to look at the shape of those scattered points, is it going in a line shape or is it not going in a line shape? So when I look at this one over here, this one right here, would you all say that this one is going in a line or it's not? It is line, so this one is more linear because that chunk of points are going in a straight way, like just a straight line. But when you look at that second one, that's like a U shape, an upside down U shape, right? So that one's not linear. Because the points, now if I took this part off, we could say that that's linear. Or if I took this part off, we could say that that's linear. But since it goes in that U shape, it's not linear. What about something that has no association? Would you say that that's linear or nonlinear? Nonlinear, because if it's not a negative or positive correlation or association, then you can't even tell which way it's going. So we couldn't even tell that it's going in a straight line if it was not negative or positive. Okay, down here, it says use scatter plots A through D to answer the questions below. So, which scatter plots show a linear association? So let's all look at them. So it could be one, it could be more than one. But I want you to look at them and figure out which ones you think would be considered to be linear. All right, Karen, tell me one of them. Okay, C, that's correct. Brody?
B.
And B. And those are the only two. This one has got a curve to it, so that's why it's not linear. This one, the points are all going up towards a straight line. These are all going to a straight line, and this has a curve. So that's why that one's not linear. All right, 5. And we just answered that. Which scatter plots show non-linear, which were what? A and B. Because they both had a curve to that scatter plot. Karen?
I just realized the first two are PC and the second two are AB, like.
Oh, BCAD, yeah, like after and before. Yeah. Okay, number 6. Don't yell it out. Which scatter plot shows the weakest association? So which one is not the strongest? It's the weakest. All right, Cameron? C. See, those points are the most spread out. So that's why that one is the weakest. The last one, which scatter plot shows the strongest? Savannah? A. Those points are super clumped together. There's really no space between them, so that's why it isn't. All right, I'm going to let you all answer these three on your own, and then we'll go over them. So it says 8 through 10. Draw a line from each scatter plot to the best description of its association. So like if this one's positive and linear, you would draw a line here, which is not. And then after that, it says then to the variables that would most likely represent. So would you say that this would represent which one of these? So you'll draw a line. And then not all choices will be used. So I'll give you all a minute to do that. All right, on 8, would you all say that that one's positive, negative, or no association? No association. The points are just kind of everywhere. They're not increasing from left to right. They're not decreasing from left to right. So that one is no association. Okay, so then we've got to figure out no association. Which one of those would it be? Like temperature outside and the total gallons of gas sold at a gas station. Do those have any type of relationship to each other? No, so you're right. Okay. The number 9, is that positive or negative? Positive. Is it linear or non-linear? It is linear. It's positive and linear. It's going up from left to right, and it's pretty much in a straight line there. All right, so it says the altitude of a hiker and the total oxygen level in the air, or the size of the home and the cost of the monthly utilities. Which one?
Yeah.
The home. The home. Because the bigger the house, the more the utilities cost. So that's an increase and an increase, which makes it positive. All right, the last one is obviously negative, but is it linear or non-linear? It's linear. Okay, so it's negative and linear, and then obviously it goes with this one. The altitude of a hiker, so the higher the hiker gets, the less oxygen is in the air. So that's a high and a low, opposite, increasing. Okay. Are there any questions about association? Okay, we are going to play a little bit of book it. Also, tomorrow, I'm going to give us a worksheet in class to do, which is our homework that I'll give you towards the end, but we should have time to do in class. And then we're also going to do like a little activity with a partner answering questions. Yeah. Well, pretty much neither, because it's non-linear. I guess you could say like if it is in a U shape up here, you could say that it's a positive association up until this point, and then it's a negative association from that point. You have to kind of break it up. All right, so no homework. Let me